So I have a problem that says the distance in miles, we're going to use D for distance, that a runner travels is given by the function D equals 6t, where t is the time in hours spent running. That sounds like a mouthful. That sounds so silly and ridiculous, like, whoa. Do you guys know by now, whenever you see something like that, they're telling you the unit rate? So if I say you make $8 an hour, y equals 8x. If you're driving 60 miles an hour, y equals 60x. If each CD, like the last test, costs $12.99, y equals $12.99x, right? So when you see that, do you know what that means by now? Okay, so big deal. Y or D equals 6t, y equals 6x, whatever you want to say, okay? So here's how this is going to work. We have to talk about the difference between the independent and the dependent variables. So I know you've learned these terms in science before, right? So think about what dependent is. Dependent means whatever it is depends on something else, okay? So do you think the distance depends on the time or the time depends on the distance? This is one of the weirdest, trickiest, yet easiest things to think about. How far I go depends on how long I've been going for, right? So if this person is traveling 6 miles per hour as they're on this light jog, doesn't the distance depend on the time? If they're running for 1 hour, they've gone 6. If they're running for 2, right? So the independent variable, I gave you a huge hint, 90% of the time, it's going to be time, right? So this is time. That is your independent, okay? And by the way, your independent is your x all the time, which means your dependent is going to be distance. Because the distance you go depends on the time, okay? So now, let's talk about this. Actually, determine whether there is a domain or a range restriction. I want you to read this sentence right here. The runner plans to go for an 1.5-hour run. They say, okay, I have a marathon coming up. I'm going to run for an 1.5 hours straight, regardless of what my distance is. I might cover 10 miles. I might cover 12. I'm going to run for an 1.5 hours and not stop. So what you need to decide is, what is that restriction? It's a restriction on the hour. And what is hours? It's my time, correct? So I am coming up with a time restriction. So what variable is being restricted? Time, which is my independent. Which is also, we're going to say, domain. I don't really care about the word independent right now. I want you to know that there is a domain restriction, okay? So now, what I want you to think about is, just like yesterday when I said, okay, your domain has to be greater than or equal to 0, or if you're talking about having friends over for a sleepover, your mom says the number of people you can have to be less than or equal to 8. That's a restriction, right? How would I write that restriction? In terms of, I'm only running for an 1.5 hours and nothing longer. I'm not running for 2 hours. So you're going to write it combined, just like we did before. So first of all, it's my domain that's restricted, which is my x. What's the least amount of time that I can run for? Can I run less than 0? No, you can't have negative time. So I can run. And be careful, because this is red. X is greater than or equal to 0. But what's the most I want to run? An 1.5 hours. So doesn't that have to be less than or equal to 1.5? Everybody agree with that? Okay. So I want to run less than, or I want to run in between 0 and an 1.5 hours. Okay. Create a table of values, keeping in mind your variable restriction. So first thing I want you to do is this. X is my domain, and I think it's really helpful for you to list what your X is and what your Y is, distance. You could also put hours and miles if that makes you more comfortable. And then this is obviously your independent and your dependent. Your distance depends on how long you've been running for, as simple as that. So what I want you to always start with including is, I didn't even start running yet. The timer still says 0. How far have I traveled? 0. Okay? Now, here's the thing. I only want to go up to 1.5. So whatever I do, my domain restriction says stop at 1.5. Don't just go 0, 1, 2, 3, 4. Do you understand? The purpose of this lesson is about restrictions. So this is going by 5s. Why don't we just go by half an hour? Okay? So I'm going half an hour, 1 hour, an hour and a half. Because what I'm going to ask you for next is if I have this domain restriction, what would my range be? Now, I already know if I'm running for 1, I'm at 6. Use this equation. It's really helpful. So if I'm running for a half an hour, how far would I have gone? Just 3, right? So if I'm running for an hour and a half, I would run a total of what? 9. Okay, so we're not done, all right? Because now it's saying, all right, take this information, grab that please, and plot your points. So you have 2 graphs, so you're going to just hand draw one in. I'm going to just use this one on the left here. This is my time, and this one is my distance, right? So go ahead and just kind of draw that in there. Well, look at, the highest I need to go is 1.5. Am I going to go by ones with these itty-bitty little, no way. Look what I'm going to do. This is always 0. I'm going to skip 4. 1, 2, 3, 4, and I'm going to make that 0.5. Then I'm going to go 1, 2, 3, and on the next 4th, that's my 1 mile. And then 1, 2, 3, 4, 1.5. I have made good use of my domain axis, my x-axis. So now, let's go back up and think about what this means. If this guy says, I'm only running for an hour and a half, what is the most distance he's going to cover? 9. His range will never go past 9 because he promised to only go for an hour and a half at that speed. Follow me? So now I got to look here to decide what to make my y-axis. I'm just going by ones. 1, 2, 3, 4, 5. I might only list 2, 4, 6, 8, 10. Okay? You don't have to list every single one. And now I plot. You don't move. The time doesn't move. You don't move. That first half hour, he has already traveled 3 miles. Here's my unit rate, that 1.6 that was given in the original equation, right? And after 1.5 hours, which is his max, he's not going past 1.5 hours, he will have traveled 9 miles. So stop, because the wrap it all up is what do I do with those points? Do I connect them? Do I put an arrow? If I said there's a guy, he's going for a jog, he's going to run as long as he wants, then put an arrow and he can go as far as he wants and as long as he wants, right? But he wants to stop at an hour and a half. So everything needs to take place between 0 and 15. So I connect. Do you know why I connect? Because can he run for an hour and 20 minutes here? Yes, he can run in between. So, after all that, you ready? I got one final step. Now that you have a table and a graph, I don't care which one you look at, I need the range. Will somebody open that? So take a look at the range. The range is what's the most amount of distance he could cover and still, hey Hayden, what's up? Need a retest?
Yeah.
Okay, which one?
Standard 5 edition.
Okay, the new one or the old one? That one? Okay. All right, let me get
Multi-step.
this. Yep. Okay, so that's this one. There we go. Go ahead and have a seat. Yep. Okay, so does that make sense? So look what I did. I found first of all, I had to identify the restriction. And the restriction was time, which was my independent. I plugged it in. I found my range. Now I need to write this. And this is my range restriction. Basically, that's how you write in between. As long as I put the 0 here, so he can run anywhere from 0 up to 9. He will not go over 9 miles if he put a restriction of an hour and a half on it, correct? Okay. How would it change it up if instead of saying, hey, this guy's going to run for an hour and a half, what if his goal was reversed? What if he says, my goal today is 12 miles. I'm not going to stop running until I have, my Garmin says 12 miles on it. So what is that restricting? It's restricting the range, right? So how would I do that? Do you have to make a whole brand new table? Could you just use this table? I would just have to maybe extend this a little bit, and I would have to know to put what here? 12. And now, what is his new domain? 2 hours, right? You could use your table to continue the pattern, or you could literally plug 12 in for your distance. So down here, I'm saying if D equals 6T, and he decides that instead he wants his distance to be 12, put that here, solve for T, and his time is 2. Got it? So, watch this. It all comes down to this. It's written like this. So with a range restriction of 0 to 2 hours, or what did we say, 12 hours? 12 miles, sorry. What would his domain restriction be? It would be 2. Does that make sense? If you want it, I didn't use D for domain and R for range here because kids thought that D meant distance. So you are basically working on figuring out which one is restricted. Got it? Okay, flip this over real quick. You are on a family vacation. You've had a great time. You're 300 miles away from home. You're ready to drive back home. Okay, maybe you're going somewhere for Thanksgiving. You're 300 miles away from home. You're driving back, and you're going at 60 miles an hour. You're not on the expressway. You're on some little back road, so you can't go 80. The distance in miles that you travel is 300 minus 60T. Are you listening? This is a little crazy. Where T is the time spent driving, and the D is your distance from home. Okay? So does this make sense to you? How far away from home are you? 300 miles. And every hour that goes by, you're getting 60 miles closer. Okay? So let's go with this and figure this out. What is your independent and your dependent? So your dependent is your independent is your time. And in this case, we're also doing distance again. Okay? I just want you to see what this graph looks like. Determine whether there is a domain or range restriction. This says how many hours will it take you to get home. So they want to know when is your distance from home going to be 0. So let's take, actually this one doesn't have any domain or range restrictions. Let's just go right into this. So if this is your distance, this is time. This is distance. This is so important. From home, if you haven't gotten on the road yet to head back, be careful. How far away from home are you? You're still 300 away, correct? Okay? So every mile or every hour that you drive, you are 60 closer. We may not have enough spaces here. You may need to just kind of split these into 2. And we don't have to go by 60 every single time. Could we go by 2, 4, 6, 8? Maybe we didn't really need to split it, but. So 2 hours into my drive, I have gone closer to home by what? 60 plus another 60. So what would this number be? What would my distance from home be? Think about that. I'm 120 miles closer. Yes. 180. Okay. Another 2 hours goes by. I'm another 120 from home, which would be what? 60. Okay. And then do I need to go another 2? So I only need to get back to home. So it's kind of like if this is 5, am I home? Yes. You understand what that means, okay? How would I graph this? I graph it by starting at 0, 300. But I have to label some axes, right? So go ahead and put this as distance, just sketch yours in, from home. I gotta go all the way up to 300, so let's just go 50, 100, 150, 200, 250, 300. That's perfect. 300, 200, 100. Okay? So here's where we talk about domain and range restrictions. If I'm home after 5 hours, will I be in the car more than 5 hours? No. So I probably didn't really need the 6 and the 8, right? Because my range was restricted to 300, my domain was only restricted to 5, okay? So we're going to go at 5. I'm going to skip a couple. Let's just skip 1, 2, 3, 4, 5. I just skipped every other one. And so now when I graph this, I did this one on purpose because I wanted you to kind of see what the graph looks like. I'm still on vacation. I haven't pulled out to come home yet. I'm still 300 miles from home. But after 1 hour in that car, we could use 2. After 2 hours in that car, I am only 180 miles away from home. So I have to just kind of eyeball it. If this is 150. 4 hours in the car, I'm only 60 away from home. And finally, after driving for 5 hours, I'm home. It's a long way, right? So does that make sense to you? So as I connect these, I don't put arrows because there is a domain and a range restriction. Let's wrap this up. I kind of feel like, is it easier for you to write the domain and the range restriction from the table or from looking at the graph? Probably the graph, right? Because how far to the left does this go versus how far to the right? So I'm somewhere in between 0 and 5 hours. Agreed? And do you agree that that's your domain? So you're going to say your domain is in between 0 and 5 hours. When your range was what? Somewhere in between what? Yes. 300 and 0. Got it? Okay. And then it might ask you a question about this. It might say, all right, you've been on the road for 3.5 hours. How far are you away from home still? So you know what you have to do? Don't forget about this amazing equation that is here to help you. Where do you put 3.5? Is it a T or a D? It's a time. So I put it there. I multiply it by 60. And I get what? 210. Yes? So D is equal to 300. And you got 3.5 times 60, which is 210. And D is equal to 90. I'm still 90 miles away. I'm still an hour and a half away. So this is what